this video, we are going to attempt MCQs questions related to enthalpy change. So first question is that which of the following statements correctly describe the energy change associated with bond breaking and bond formation? So first of all, bond breaking is basically an endothermic process in which heat energy is absorbed, and bond formation is exothermic process in which bonds are formed and energy is released. So heat absorbed here, and heat is released here. So now, if you see option B, they are saying bond breaking is an endothermic process, absolutely right, and bond formation is an exothermic process. So answer is going to be B. So in this question, they are saying that which are the possible values for standard enthalpy of formation, combustion, and neutralization. So if you are going to see this question, and enthalpy of formation, which is when one mole of a compound is formed from its elements under standard conditions. So this is either going to be like, and its enthalpy change is either going to be exothermic or endothermic. So it can be either be negative or either be positive. Negative is for exo and positive is for endo. So enthalpy of formation can be both of them. Then after this one, they have told us about the combustion. Remember, combustion is when one mole of a compound has been burned in excess of oxygen, and that is always exothermic, negative enthalpy change. It is always going to be exothermic, and for neutralization it is also going to be exothermic, having negative enthalpy change. So it is always be exothermic. So if we are seeing this question, and if we see option C, they are saying enthalpy of formation can be positive or negative, absolutely right, while enthalpy of combustion and neutralization are negative as they are exothermic. So option C is going to be the right one. Then they are saying which of the following is going to have highest bond enthalpy. So when you are seeing nitrogen exists as N2, and there are 5 electron in its outermost shell. And what happens when it makes a bond with another nitrogen? So it is basically sharing 3 pair of electrons like this. So it is sharing 3 pair of electrons, and this is nitrogen having nitrogen triple bond. So it is going to be C. So in this question, they are saying there are 3 reactions. If you can see here, the first is when HNO3, which is an acid, that reacts with ammonia, which is a base, to form a salt. So this is basically a neutralization reaction. And if we see three of the reaction, they are enthalpy of reactions, because they are following the stoichiometric equation. And if you see first one, then that is going to be enthalpy of neutralization as well, because acid and base, they react to form salt. So that is enthalpy of neutralization. And if you see the second one, that is only the enthalpy of reaction. And if you see the third one, then that is going to be enthalpy of combustion. as well as enthalpy of formation as well. Why formation? Because you can see 1 mole of a compound has been formed from its element. So which option is going to be the right one? Now they are saying enthalpy of combustion, that is going to be the third one, that is going to be described either by this, either by this. Enthalpy of formation, if we are saying, then that is not 2. Okay, that is the third reaction. And if they are saying about enthalpy of neutralization, then that is going to be the first one. Enthalpy of reaction is 2 as well. So option C is going to be the right one. So in this question, they have given us this reaction. Let me draw this reaction here. TiO2 plus 2C, and it is going to form Ti plus 2 carbon monoxide. So first of all, let's draw the rectangles like this one and this one, and they are saying they have given us enthalpy of formation. So we have to draw elements here: Ti plus O2 plus carbon. So if you are seeing TiO2, that has been formed from its element, and its enthalpy of formation is minus 890 kilojoules per mole. If you see for carbon monoxide, that is going to be at this point, but there are 2 moles of carbon monoxide has been formed, so 2 times minus 110, and enthalpy of reaction we have to find at this point. So all the arrows are initiating from this point, so this is going to be the starting point, and all the arrows are ending at this point, so this is going to be the ending point. So the first root that we are having at this moment is this one is going to be the first root. So this is root 1, and second root is going to be the this one. So this is root 2. So we know in Hess law, root 1 energy is going to be equal to root 2. So that one would become minus 890 if we are going from this side, plus enthalpy of reaction is equal to root 2, that is 2 times minus 110. So this one would become minus 80 plus enthalpy of reaction is equal to minus 220, and enthalpy of reaction would become minus 220 plus 80. So that is going to be how much? That is going to be we have done, oh, it's minus 890. Okay, and this is 1, so it's my plus 890. So our answer that comes out to be 669. So that is going to be the option A. That is going to be option A. That is like around plus 670 kilojoules per mole, and that is option A. So in this question, they have given us the reaction, which is going to be, the reaction is here when ethanol C2H5OH is reacting with oxygen and is burning to form 2CO2, and it is forming 3H2O. And what they have given us at this time, they have given us enthalpy of combustion. So let's write the elements here, which are carbon, okay, because they have given me the enthalpy of combustion for carbon. For hydrogen, carbon is this and hydrogen is this one. Okay, let me put it like this. So now what is happening if we are going to form, let's say, carbon dioxide? So you can see that for carbon dioxide, what needs to be burned? 2 mole of carbon needs to be burned. Okay, if we, let's say, first make it in this way, and this is going to be this way. So you are going to see that for carbon dioxide, 2 moles of carbon needs to be burned. So for 1 mole, the value is minus 394. For 2 moles, it is going to be minus 394 times 2. And if it is going to be 1 mole of hydrogen, then it is going to be minus 286. And if it is going to be like they are forming 3 mole of water molecules, so that needs 3 hydrogen to be burned, and that is going to be like this. And how many hydrogen is burning? So 3. So 3 times this value, that is minus 286. And enthalpy of combustion for ethanol is minus 1367. And we need to find out what? We need to find out enthalpy of formation for ethanol. Enthalpy of formation for ethanol is this one, and that would be delta H of F. So now, how can we find it out? Again, we are going to develop the roots there. So first root is going to be from this point to this point, as this is a starting point from where all arrows are initiating. This is ending point from where all arrows are ending. And this is going to be root 2. This is root 1. And this is root 2. So now let's make the equations for that. From root 1, as we are saying, we have delta HF first minus 1367 is equal to, from root 2 we have 2 times minus 394 plus we have 3 times minus 286. So enthalpy of formation after calculating them, that comes out to be minus 279 kilojoules per mole. That is option B. So in this question, they are saying the first stage in the industrial production of nitric acid from ammonia can be represented by the following equation. So they have given us the equation, and now they have given me the values of enthalpy of combustions only. So in order to find out the enthalpy of reaction for this question, we would be using the formula summation of enthalpy of combustion of products minus summation of enthalpy of combustion of reactants. So what about the combustion of products? Products are 4NO and 6H2O. So for 4NO, what you people are going to do, we are going to put a bracket for the product. Product is NO, and there are 4 moles. So this is going to be multiplied with 4, 92.2, and plus it is going to be for product, that is 6 water molecules. So 6 times minus 2, 39.6, minus that of reactants, which is 4 ammonia. So 4 times ammonia is minus 551.3. So that is minus 51.3. And when we are going to solve them, the answer that comes out to be around minus 863.6 kilojoules per mole. And the answer is going to be C. So in this question, they want to find the average bond enthalpy. They want to find out the enthalpy change for the combustion of ethene, and they have given us the average bond enthalpies. So first of all, what is ethene? Ethene is C2H2 plus oxygen. They would be forming CO2 plus water molecules. And let's balance it. Sorry, ethene is C2H4. Ethene is C2H4. Now let's balance it. So it is going to be 2CO2, then it is going to be 2H2O, and how many oxygen becomes? There would be 3O2. So if I'm like drawing the structure, so it is going to be like this: C double bond C, hydrogen is here, here, and there are three oxygen molecules, so they are going to be like this. And there are basically two carbon dioxide, so it's going to be O double bond C double bond O, O double bond C double bond O, plus oxygen, hydrogen, hydrogen, we have lone pair here, and then two water molecules. So now what actually happens, the formula that we people are going to use is that enthalpy of reaction is equal to energy absorbed during bond breaking, energy absorbed during bond breaking, during bond breaking, and we know bond breaking occurs on left hand side, minus energy release during bond formation, during bond formation. So it's going to be how it is going to be done. Like first of all, there are how many carbon carbon double bond on left hand side? So let's see, that's going to be one carbon carbon double bond. Then how many carbon hydrogen bonds are there? There are 1 2 3 4 4 carbon hydrogen bond. And how many oxygen bonds are there? 3 oxygen oxygen double bond. So this is going to be like this, minus energy release during bond formation. How many carbon oxygen double bond are there? There are 4 carbon double bond oxygen, plus how many oxygen hydrogen bonds are there? There are 4 oxygen hydrogen bond. So that is how much? 612 for carbon carbon double bond, and for there are 4 carbon hydrogen bonds are there, so that is going to be 412, plus there are 3 oxygen oxygen double bond, that is 496, minus how many 4 are for carbon double bond oxygen, so that is 805, and plus 4 into oxygen hydrogen bond are 463. Okay, so now we are going to just solve them, and the answer that comes out to be is going to be minus 1324, minus 1324 kilojoules per mole. So the answer is going to be B.